Welcome back, geometers. Today, we are going to transition into 7.2. And in 7.2, our entire focus is still regarding this idea of similarity, but we are going to look more specifically at some similarity transforms, or transformations, if you would rather. Okay. Now, as we're looking at these things, when we do a transformation, remember, we're just finding some mapping. We start with our pre-image, we change something about it, and we get to this new location, normally, this new location that gives us the image after that. We have dealt with 4 different types of transformations so far this year. 3 of them that we focused on were isometries or congruence transformations, and then we got introduced a little bit to this new one yesterday. 4 of them total. One of them, we can volunteer them. The sooner you speak, the easier your choices are. 4 transformations that we've dealt with. Dilations. So I'm going to write these down just as we go. Dilation, and if you want to tell me to dilate something, you have to give me some additional information. What are they? The center. So I'll write that as C here. And you can give me something else too, though. The scale factor. So we have one way of writing them. Now, I do think that this is backward, but in the end, I'm okay as long as you know what you're doing with it. What other sorts of transformations have we had? Rotation. What's the symbol for rotation? Love it. If I want to rotate something, it's a capital R is the way that we write it down. What do you have to tell me if I'm rotating something? The point or the center that we're doing it around, and the degrees. So we have to know how many we're going with. Throwback. If I just tell you 5 degrees, do you go clockwise or anti-clockwise? Counter is a more common word, just for the record. We go counter, and it's weird, but we would go counterclockwise. Okay, another one. We're down to 2 left, so it's getting harder. Reflections. What do we use to represent a reflection? A lowercase r, and I only need one thing here. The axis that I'm reflecting over, right? So typically we write that as a subscript using just whatever line it is. It could be x equals 1 or y equals x. It doesn't matter. Okay, one more. Somebody who hasn't spoken. We get dilations, rotations, reflections, translations. And Camille, just real quick, is there a particular photograph scene that one might think of when trying to imagine how to remember translations? Every time, right? We use these lovely Instagram brackets to indicate it's a translation, A and B, whatever those happen to be. So we have dealt with all of these this year. Now, what's the difference between this and these 3? These are all congruents, which just reminds me, if 2 things are congruent and we write the symbol with this, what does that actually mean? Same shape, same size. This one, will it always mean not congruent? Is there a weird scale factor that we could use that would make it the exact same thing? 1. It could be the same. Now, instead of being congruent, guaranteed, we can't say that. What's the other word we use? Similar. So I'm going to introduce something real quick just so that we have it. Similar. Have we looked at the shorthand for this yet? I'm going to hook it up right now. It might be a little bit early, but just so we don't have to write similar or similarity a million times. If they're congruent, it means they're equal size, right? So that's the equal symbol in my congruent. What do you think this tilde might mean? All the measurements are equal. That says it's the same size. And then this might add the other part to it. Same size, what's the other part of it? Same shape. So equal means the same size. What do you think this little tilde right here means? We have a shorthand for similar. It is just a tilde. If the tilde is standing alone, that is the shorthand for similar. Okay, now as we're dealing with these, what we're going to be looking for, and we're going to have to play around with all of these, so if we need tracing paper and that good stuff, we'll get it out. Because we're just going to jump in and see, have we done a significant amount of rotations and reflections and transformations and stuff this year? And did we write it all down, or did I expect you guys just to remember it perfectly all the time? Oh, so we wrote it down. So it means if you don't remember how to do it, do we have a way to reference and like get that knowledge, even if it's not just right here and ready to be recalled? My gosh, you're going to look where? All right, fantastic. So with that in mind, here's the first little thing. You guys need to use your notes. And I'm going to throw you right in the deep end. I'm debating if I'm going to do this with Zeke because he won't stick his face underwater, but he can swim. So maybe he'll also get thrown into the deep end, just in a very much more literal sense. Here's my challenge for you guys. I want you to look at this here, and we're just going to see where it's at. We'll talk a little bit about this thing before we get started, but we're going to look at the try it problem, and we're just going to jump right in with an example dealing with these. So 5.2, we're dealing with these transformations, similarity transformations. We did a review of all this old stuff. We're going to jump right in here to an example, and I'll make sure we have it nicely. So I want us to work with the following. Given triangle, and I'll put it back up if we need it, but we'll just write it out here, x, y, z, with the following points. And I'm going to write this very specifically. I'm going to leave a little space just so we don't have to write it twice. We're going to start with point x, and we'll call this A, and we'll put direction here in a second. We'll say point x is the point 3, 5. Point y is the point negative 1, 4. And z is 1, 7. So I've given you these coordinates, but because we're going to do the mapping notation, I've just written them down here in preparation for that. So using your collective knowledge and resources and the solid notes that you've taken, because I take the time to write your notes nicely, we're going to do the following. I want you to find the image if we do the following. And we're going to say this one is going to be ugly, and we'll make sure that we get this knocked out. I'm using brackets just so we can see it better. It's a capital D with a 2, and then an open circle, not an O, but an open circle, and then this lovely capital T with a 1 and negative 2 hanging out inside those wonderful brackets. Okay, couple ways we can go through this. You guys all love graphing, and I get email after email saying, Mr. Holloway, can we please do some more graphs? Everybody loves graphing, and we want to do more of it. If you want to, you can. I'm going to suggest, though, that as long as you have taken notes and you don't throw away your notebooks every night when you go home, I think that collectively, working with your neighbors and each of your notebooks, we can work this out. The only thing that I think we need to cover is which thing happens first. And what is this thing? That's a dilation by what factor? 2. What didn't I give you? So if I didn't give it, where do you think the implication that it is? That was a weird way to word it, but it's safe to assume the origin. What's this tell me to do? What direction? How many? 1 to the right and then 2 down. Last question. What happens first? Do we translate first or dilate first? Look at me. Translate. And the reason and the way that we can justify this is if we really do it, it'd be the dilation composed with the translation of triangle XYZ. Which one's closest to XYZ? Which one's going to touch it first? This is our first. This is our second. Now, I'm going to move this down just a skosh so I don't have to erase a bunch. But what I want you guys to do with that in mind is using those wonderful resources that I keep alluding to over and over and over. You're going to give me my mapping. You're going to show me that you can map this with this first. And then you're going to get x prime for now, whatever it is. And then after we translate it, what do we have to do? Or what do we get to do, rather? We dilate by a factor of 2. Cool. It's been a while. This was chapter 3 stuff. This is chapter 7 now. Good thing we take notes. Sweet. Here's the deal. 5 minutes with a throwback problem I think is reasonable. If it takes you a little bit longer than 5, bummer. But the good news is, or bad news for you, is that I don't get to see you again for 23 more hours. So by the time you show up here tomorrow, you need to show me that you've done this problem. Cool. I'm going to give you the last 5 minutes to continue this. This is a natural place to leave off.